Chapter 4, Section 3, Proving Triangles Are Congruent by Side, 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 and Side, Angle, Side Congruence Postulates. The side, side, side congruence postulate says that if three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. We talked in the last lesson about congruent triangles and congruent polygons. For triangles, there are going to be ways to prove that they are congruent without proving that all corresponding parts are congruent, meaning all three corresponding angles are congruent and all three corresponding sides are congruent. That's 6 different things to prove that you have congruent triangles, but there's going to be shorter ways, and one of them is the side, side, side congruence postulate. This first example asks us to prove that triangle KLM is congruent to triangle NMP. If you notice in the picture that they've given us, they tell us that KL is congruent to NM, they tell us that LM is congruent to MP, and that KM is congruent to NP because of the tick marks that they've shown. KL and NM both have 1 tick mark. The other 2 of them have 2 tick marks, and the others have 3 tick marks, showing us that they are congruent. Because I have 3 congruent corresponding sides in the 2 triangles, using the side, side, side congruence theorem, I can say that triangle KLM is congruent to triangle NMP. Notice I didn't have to say anything about the angles. Because of the side, side, side congruence postulate, knowing that all 3 sides are congruent to 3 sides of the other triangle is enough to prove that we have 2 congruent triangles. The side, angle, side congruence postulate, we can write just as SAS to shorten it, says that if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of a second triangle, then the 2 triangles are congruent. Really quickly, 2 sides and the included angle means that we're going to know the length of the 2 sides that are creating the angle measure that we know. So we're looking at 2 sides and the angle that is created by those 2 sides to use the side, angle, side congruence postulate. This example asks us to prove that triangle VWZ is congruent to triangle YWX. Notice that they've given me that ZW is congruent to WX and that VW is congruent to WY by putting the tick marks on the side lengths. We do not have any information to help us find VZ and XY's lengths and to say that they are congruent, so I'm not going to be able to use the side, side, side. But if you notice, the 2 sides that I know the length of are creating the 2 angles VWZ and XWY. Those 2 angles are vertical angles, so I can say that they are congruent to each other by the vertical angles theorem. So now I can say that angle VWZ is congruent to angle XWY because of the vertical angles theorem. Notice I know that 2 sides and the included angle of triangle VWZ are congruent to 2 sides and the included angle of triangle YWX. So I can say that the 2 triangles are congruent to each other because of the side, angle, side congruence theorem. This example asks if is there enough information given to prove that triangle LMP is congruent to triangle NPM. Notice that they tell us that LP is congruent to MN, and they tell us that PN is congruent to LM. The third side of both of those triangles, they're sharing the side PM. If you think way back at the beginning of this year, we talked about a reflexive property of segment congruence, which basically says that any segment is congruent to itself. I can use that reflexive property to say that PM is congruent to PM, and then I have three sides of one triangle are congruent to three sides of the other triangle, and so I can say that there is enough information given. We can use the side congruence postulate to show that the angles are congruent. This next example, we are given that segment AB is congruent to segment PB, and that segment MB is perpendicular to segment AP. They're asking us to prove that triangle MBA is congruent to triangle MBP. Remember, we start our two-column proof with our givens, so go ahead and write that AB is congruent to PB and that MB is perpendicular to AP, and the reason is that they are given. Now, if you look at this diagram that they've given us, notice that AB and BP are helping to create this right angle that is formed by the two perpendicular lines. If you notice that right angle is formed by AB and MB for triangle MBA, and then it's formed by side BP and MB for the triangle MBP. I should be thinking side angle side right now because I do have a side and an angle. There's no way to find the hypotenuse of this, which would be sides MA and sides MP. So side is out. Let's start with the fact that we have that we have the two triangles are sharing side MB. I can say that segment MB is congruent to segment MB because of the reflexive property of segment congruence. Now I need to prove that I have two congruent angles, the angle that is included in my two congruent sides, which would be the right angles formed by the perpendicular lines. So I'm going to say that angle MBA and angle MBP are right angles. And the reason why I can say that, not only is it shown that MBA is a right angle, but it's the statement that perpendicular lines form right angles, or it said perpendicular lines form four right angles. And then I can say that angle MBA is congruent to angle MBP, because if you remember, all right angles are congruent. Then I have side angle side of one triangle is congruent to the side angle side of another triangle. So I can say that triangle MBA is congruent to triangle MBP because of the side angle side congruence postulate. This last example asks us to use side to show that triangle NPM is congruent to triangle DFE. If you notice, we have two triangles in a coordinate plane. We are not directly given the lengths of each of these sides, however, the sides of the triangles. However, I can use the coordinate plane to find them. Let's start with the triangle on the left, and if you notice the distance from point N to point M, or the distance of the side that's on the bottom of this triangle would be 4. I can use the coordinate plane to just count the units since it is a horizontal line. And I can do the same thing on the right side of the triangle DFE and find that the length of DE is also 4 just by counting across. I'm going to use that same idea to find the length of MP, but just by counting I find that it's 5 units. And for EF, I also find that it is 5 units on the triangle on the right. Now, to find the length of the diagonal sides, the NP and FD, I am going to use the distance formula. So for NP, I would say the square root of -1 minus -5 squared plus 6 minus 1 squared. When I do that, I find that the length of side NP is the square root of 41 units. I'm going to do the same thing for side FD or DF. When I do that, I have the square root of 6 minus 2 squared plus 1 minus 6 squared. 6 minus 2 is 4, and 1 minus 6 is -5. When you square them and add them together, you get the square root of 41. So notice I have 3 congruent corresponding sides between these two triangles. So I can use the side congruence postulate to say that the triangles are congruent. Today's assignment is on page 216. It's numbers 6 through 20 and 22 through 28 even.